This customer has deployed our solution in Azure. So it's like the primary cloud is Microsoft Azure, and they have plans to extend it to other clouds as well. Okay, so that's the background of this customer. Now, if you look at their business objectives, so I just changed the name to Globex Corp here. So the requirements are pretty, obvious. This is the same trend I see in majority of the cases where customers, they come to us and they tell us that they have different type of workloads. It's a test, dev, and prod, and obviously they want these workloads to be segregated. So they want to provide some kind of segmentation. Okay, so we have the security group or network security group, but sometimes that's not enough. They want to go and then create the policies using the controller so that these workloads are not talking to each other. Okay, they have the shared services VNet, and they want to make sure that these workloads are actually talking to the shared services, because in the shared services they have deployed some tools and some services that are shared between all these different workload types. Okay, they are in the process of migrating from their on-prem data center to cloud. So their plan is that they will shut down the physical data center in about 1 year. But in the meantime, they need high throughput access from the cloud towards the on-prem location, and it has to be dedicated. And they don't want to go over internet because it's highly secure data that they're sending through. The developers, when they need to work or deploy the code in the cloud, they want to have a solution where they can just directly VPN from their laptops in a most secure and in a profile way, so that only the production guys have access to the production workload, and the testers, that they should be able to access only their test VPCs. So they want to have a solution that can provide this level of security for the remote users. Deep packet inspection is a must because they have this critical workload running in the production VNet, and due to the compliance reasons, due to the PCI reasons, they must inspect all that traffic that is going into that production VNet and coming out of this. And obviously, they don't want to have all the traffic inspected. So they want an easy way to create a policy and apply it to the workload. And obviously, this architecture, whatever they're building, it should extend to other clouds when they move into other clouds. Okay, so now let's take a look at how we can actually solve this problem and how we can create this architecture for them. So the first thing for you to remember is that now you have this frame of reference. You have a reference architecture called MCNA, Multi-Cloud Network Architecture, and you know the layers there, right? So if you have this laid out on a piece of paper or drawing board with the cloud access, transit network, and application layer, and what you're gonna do, you're gonna deploy the controller first from the Azure Marketplace. Okay, so that's step number one. The Copilot is optional, but since these guys they need extreme visibility, obviously they're running critical data, so they wanted to have this extreme visibility so that they can troubleshoot even further. So in order to meet the requirement number one, they have created these different VNets, and they also created a shared services VNet for the common services that these VNets are going to have access to. Then they created a transit VNet, because what I'm showing here is just a snapshot of their actual topology. Obviously, they have more than 3 VNets. And if they go with the native peering option, they have to create a full mesh. It's not scalable. It's not visible. It's very difficult to actually manage and even operate. So they are choosing the transit VNet architecture, which is the right approach. They deployed our gateways through the controller, or they can use Terraform or our API, REST APIs. And they have all this connectivity done automatically through the controller, okay? So you can see in the production, you will always deploy 2 gateways in a spoke and also in the transit for the high availability. And we are showing only one link here. And by the way, this is encrypted. Like I said before, by default, it is all encrypted. But under the hood, we have enabled the active mesh for them. So there are actually 4. And if you want to enable HPE, high performance encryption between your spoke and transit, we can actually build even more tunnels and we can give you more throughput, but that's not the requirement, at least for this portion. So they're keeping it, keeping the active mesh for now. Now, if you look at the other requirement, the high performance encryption, for that they have purchased the express route. It's a 10 gig link that they have purchased. And obviously they want all the data in motion to be encrypted. And they know that if they just use the VPN, IPsec VPN, then the performance is only, or throughput is only 1.25 GB. That's all they can get. So they picked up our solution where they deployed our hardware appliance in the on-prem data center. And they are encrypting this dedicated link to meet the second or third requirement. The fourth requirement, if you recall, was the users who were or who wanted to actually log into their own respective workload, right? So this is where we positioned our user VPN solution, because it's a SAML-based smart VPN solution that allows them to create the profiles based on the users, and you can authenticate and authorize them using the ID providers like Okta and Duo. So now when it comes to connecting these users, you have 2 choices. Number one is just to land them directly into the transit, right? So they log in and come into transit, and then from transit, they go to their respective VNets. The second option is to have a dedicated user VPN VNet. Okay, so this is the access layer. And this is what we are proposing to them. This is our best practice, is to land those users into their dedicated VNet. And then from there, you connect them to transit and take them to the places where they want to go. Okay, so that's the right architecture approach. So obviously they have created all the profiles, necessary profiles, and they have access to their respective VNets now. Okay, so the packet inspection. Remember, they had this important VNet, which is their production VNet, and they want to make sure that all the traffic going in or coming out from this VNet is protected by this firewall, the layer 7D packet inspection firewall. So in the architecture, what we have done, we have deployed these virtual firewalls right into the transit VNet, because remember there was a design pattern that you saw earlier, and that's the design pattern that is scalable, and it is repeatable, because remember their other requirement was to have the similar architecture in other clouds, for example AWS, when they are ready to expand it. And yeah, so this is the best solution and architecture for them to have it there. And through our controller, you can actually create the policies. So when you log into the controller, in the UI, you can specify that this is the VNet I want to protect, and we will automatically take care of all the routing and all the propagation in the background for you. Okay. They did not mention the internet requirement earlier, but they came up that we also need to have exit or egress traffic going out from here. So we said, okay, that's not a problem. That's just a checkbox in the controller. It says egress allowed or not. So you enable egress, and we will automatically program the cart 0 route respectively, and we'll send traffic out towards internet through these firewalls, all inspected through these firewalls, okay? So this is exactly what they are using it. And like I said before, all this interaction is done through the controller. We programmed everything. We are monitoring everything. It's a single pane of glass. It's also providing the necessary troubleshooting tool, right, from the controller, like the packet capture and everything, okay? And not only that, they're also shipping the data back to the co-pilot, all the net flow data that you saw in the demo. And that's how they're actually going, getting the extreme visibility. They're building their topologies. They don't have to worry about, okay, you know, what is my VNet? Is it connected to transit or where exactly it is? Some of the customers I met with, they are using the Copilot just so that they can find where the rogue VPCs are or instances are, because their environment is so big, the thousands of VPCs, you know, thousands of instances, and they don't have any way to figure out where those instances are sitting, where they're connected, do they have the right security group or not. So they are using the controller to basically crawl all these clouds and then getting the report out of it.